Okay, so today we're going to talk about Module 3, Lesson 6. This is a lesson about these things called linear inequalities. And inequalities are going to be math statements that have these symbols in them. Like this is the greater than symbol. Okay, this is the less than symbol. Sometimes we call these the order symbols as well. You might hear that phrase for these. And then there's a couple more. This is the greater than or equal to. And finally, this is a less than or equal to. There's a few tricks to working with these correctly and remembering the terms. So I like to kind of look at the less than one because it kind of looks like an arrowhead that points to the left and less both start with L, so that's a decent way to remember it. And then the greater than is like an arrow that points to the right, and greater than has that R sound in it, greater than, and like right has an R in it as well. So it's one trick. We're also going to talk about some ways to point these things in the right direction when we're trying to create our inequalities. So it's one of the trickiest parts is just remembering what the terms are and when do I use each of these order symbols. So why do we care about these linear inequalities? Well, we care about them because they come up pretty often in business and in science and just kind of the real world in general, because there are many problems where there's not just one answer to them. For example, let's say we run a car dealership and I get a incentive from the car company if I sell at least 20 vehicles, okay, in a particular month. So there's more than one answer to this. Like I would certainly get the incentive if I sold 25 vehicles or if I sold 30 vehicles, right? And then I said at least 20 vehicles, so we would write that as X is greater than or equal to 20, right? And 20 would get me the incentive in this case because that's at least 20, right? We could also just change the phrasing just a little bit, and we could consider that our car dealership needs to sell more than 20 cars to get the incentive, right? And so that would be written as X is greater than 20, and 20 is no longer a solution anymore, right? So even though these statements are very similar and most of the answers are the same, it's very, very important because if we sell 20 cars in this case, we're going to get that incentive. If we sell 20 cars in this case, we're not going to. Okay, so this is a very practical thing that we see in business all the time, where there's many solutions that are gonna satisfy an equation, and so we don't always want to use an equal sign. We want to use inequality signs instead in those cases. So if I ask you what are the solutions to an inequality like this, X is less than or equal to 5, you can't list them all. There's just too many. It's an infinite number of solutions to this thing because 5 works and 4 works and 3 works and 2 works, but there's negative numbers that would work as well, and then there's a bunch of decimals and fractions in there too. So you just can't list all the solutions in this just by listing out a bunch of numbers, right? But what we can do instead is we can represent the solution to this with a graph. And we're going to use number lines for that. So number line looks like this. It's going to go just left to right on here. And if I just label, I usually, when I'm working with these inequalities, I just label the key points. I'll always start with 0. And then 5 is a positive number. So it's going to be to the right of 0. So over here somewhere. That'll be my 5. Okay, and then I'm going to use a graph to represent this. So we talked about some possible answers here, 5 and 4 and 3 and 2. And in fact, everything that's to the left of 5 on this number line is going to be a solution to this inequality statement. Okay, and so what we're going to do to represent that is we're just going to shade this left side of the graph coming in over here to the left of 5. Okay, so all of these values. So anything in this shaded region is going to be a solution to this inequality, right? But I do have to pay very close attention to 5 because 5 is kind of where sometimes it'll be a solution and sometimes it won't. In this case, it will be a solution because of the equal sign in my inequality symbol here. So we want to include 5, when we're using this graphical strategy to represent the solutions, what we're going to do is we're going to use a square bracket to indicate that it's included. So square bracket means included in my interval. Okay, if we have a value like this very similar problem, if it was just x is less than 5, we would start with exactly the same graph. Here's 0, here's 5. We would still shade the left side, right? But we don't want to include 5 here, right? 5 is not part of my solution set, so I'm going to use a parenthesis there instead. So parenthesis means not included. And so we'll use both, kind of just dependent on what the initial inequality statement looks like. Okay, let's do one more quick graph here. So if I'm looking at a statement like this, it says 10 is less than or equal to m. I don't think it's a great idea. You know, when you have some experience, you can just graph it like this. But to me, it's probably easier for most people to deal with this by flipping it around first. Just get your variable on the left-hand side and it'll make it easier to deal with. So what I'm going to do is I'm going to just flip this around. And if I do, I have to flip my inequality sign around as well. So I'm going to start with the m. This less than or equal to is going to become a greater than or equal to. And then the 10 is going to be left over here. So m is greater than or equal to 10 is how we would read this statement. So next I'm going to go ahead and graph it. Okay, and so I want greater than or equal to 10. So I'm going to start by, put my 0 in, and then I'm just going to put 10 over here. I know that 10 is a positive value, so it's to the right of 0. You don't have to write all those tick marks in there. It will be in my math lab, but if you're just doing this by hand, this is fine. And so then I want to figure out which side of the graph I want to shade. It's going to be right or left of 10. Which side do we want? Well, I want values that are greater than or equal to 10, so values like 11 and 12. So it's going to be the right-hand side. One little trick for graphing this thing correctly is if you get it in this form where the m is first in your inequality statement and by itself, then kind of your number line has an arrowhead on it, and that arrowhead's going to have the same shape as the inequality symbol. Like the greater than symbol looks kind of like the right arrowhead, so we shade to that right arrowhead. Okay, and that'll get you to the right spot. Next thing to think about is, do we include that 10 value or not? Well, we have an equal sign in our inequality, so we are going to include that as well. Okay. Now, one other thing we'll ask you to do on some of these is we'll ask you to write it. We'll ask you to solve it graphically, but we'll also ask you to write the solution as an interval. So what that means is we're just going to describe this graph in what we call a set. Okay, and so we're going to do that by just working our way across the graph from left to right. So this interval starts at 10. So 10 is going to be the start of my interval, and then I'm going to work my way across from left to right. And this one goes to the right forever, doesn't it? So in math, when we have something that goes forever, we just say it goes to infinity, okay? And then to finish this up, what we have to do is we have to describe what happens at these endpoints. So 10 is included. We have our square bracket up here, so we're going to use a square bracket on the 10, because it's part of my solution set. And then infinity, you don't really have to think about this one. Infinity is not a number, it's not a value, it can never be included. So we're always going to use a parenthesis with this. This drives the English majors crazy because we have different symbols on both sides, but that's okay. The square bracket on the left and the parenthesis on the right, they're just telling us what happens at those endpoints, so they don't have to necessarily match up, okay? Sometimes in math, we have situations where we know that our answer is trapped between two values, okay? And to represent that, we use these things called compound inequalities. You'll notice in this problem, there are two inequality statements. And to me, what this is saying is that my x value is between negative 8 and 4. It's kind of trapping us between those two values. Let's put an equal sign on this. Okay, so if I want to graph this, what I'm going to do is go to my number line. Okay, I'm going to put the 0 in the middle, and then I'm going to put negative 8 over to the left. It's a negative value, so we know it's on the left-hand side. And then 4 is positive, so it's going to be on the right somewhere. And then my solution set for this compound inequality is just going to be this region that's between negative 8 and 4. Okay? And then, just like we have in some of the last problems, we're going to think about what happens at those endpoints. At negative 8, we are not going to include that because there is no equal sign on my inequality symbol. So we're going to use a parenthesis over here to represent that. On the other side, on the 4, okay, we've got less than or equal to. So this one is included, so we're going to use a square bracket on this one. Okay, so we're going to look at each of them individually, make our decision based on what our order symbol is in our inequality. Okay, so there's our graph. So our last question here would be to write an interval to represent this graph, and we're just going to work it just like we did the last time. We're going to work our way across the graph from left to right. So leftmost point in this thing is negative 8. So we're going to start there. We're going to work our way across, and we're going to work our way across all the way to 4. Okay, so negative 8 to 4 are going to be the values that I'm going to think about what is happening at those endpoints. Negative 8 is not included. We used a parenthesis up here, so we're going to use a parenthesis in our interval as well. 4 is included because it's got this bracket on it, so we want to include that in our interval as well. So negative 8 to 4. And again, these don't have to match up. It's okay. What we're looking for there is what is happening at each of those endpoints. They can be different. Okay, so we will get into some problems where we have a little more going on, like this one. And this looks kind of like one of the equations that we would have dealt with in Module 2, except for we have a less than or equal to instead of an equal sign here. But the good news is when we have inequalities, we can use most of the same algebra rules we did when we were working with equations, right? We can add or subtract the same values from both sides of an equation and solve for variables, just like we do if this was an equal sign. So we can use our Module 3 skills. We can move this 3 over to the other side, and we can solve like this, and then from there we're just graphing just like we have in the last few problems. Here's 0, here's 7. We want the left side, the values that are less than 7 are over here, so we would shade like this left side. And then thinking about what happens at 7, we want to make sure we are including 7. So we're going to use a square bracket over there to indicate that. Now, if we're going to do an interval for this, we want to work our way across this graph from left to right. Okay, and this one goes to the left forever. There is no leftmost point. So for that situation, we say the graph starts at negative infinity, goes to 7. Infinities and negative infinities, they are not part of your graph ever. They just can't be. They're concepts, tells you that the graph just continues on, and so we're going to use a parenthesis there to indicate that. And then 7 is part of our graph again in this case because of the equal sign up here. Because we use the square bracket here, we're going to use a square bracket in our interval as well. We can use similar rules when we're dealing with multiplication and division, but there is one exception to that rule. One thing is different when we're dealing with inequalities than it was for equations. Okay, if we multiply or divide our equation by a negative number, we have to flip our inequality sign. Okay, that's the only real difference in our algebra strategies for these inequalities than it was in Module 2 for our equations. Okay, so for this one, 3x is greater than 12. We're just going to divide by 3 on both sides, right? And we divided by a positive number, so we don't have to do anything special here. We're just going to cancel those out. X is greater than 4, and then we're going to graph it. Here's my 0, here's my 4. I want the things that are greater than 4 over here to the right, and then I want a parenthesis because we just have an equal sign there, so the things to the right of 4. For this one, though, the second one down here, negative 5x is less than 25. We're going to divide by negative 5, just like we would have But this is where you need to have a little alarm that goes off in your head. You have to be thinking about this. When we're working with inequalities, if we ever multiply or divide by a negative number, we have to flip our inequality sign. So these negative 5s are gone, right? And this less than symbol here is going to become a greater than symbol. We have to flip that thing. And then we do our division. Our 25 divided by negative 5 is negative 5. Okay, and so our graph is going to look like this. If you forget to flip this inequality sign, you're going to get the wrong graph. So you want to make sure you are thinking about that. So we want things that are greater than negative 5. That means we're going to shade the right side of our number line, and then we're not going to include negative 5 because no equal sign on our inequality. You'll have a couple of problems that get a little more complicated like this, but the nice thing about this is there's really nothing new as far as the algebra here except for that one rule. If we multiply or divide by a negative number, we have to flip our inequality sign. But if we don't do that, then we're just going to do it just like we would have back in Module 2. So it's going to be kind of a review problem. So if I'm solving this like I did in Module 2, my first step is to clean it up as much as I can. So I'm going to start by distributing this 6 across the parentheses here. 6 times 2 is 12. Bring that 5x down. Okay, then I've got some like terms to combine. I can clean it up some more. So 6x minus 5x is 1x. Okay, and then I want to solve for x. So maybe I move the 12 to the other side. Get rid of these. Negative 12 and negative 5 and negative 12 is negative 17. Okay, and I'm done because I've got the x by itself on one side. So I didn't have to do anything different here because I didn't ever multiply or divide by a negative number. But you have to be thinking about that rule because if you ever multiply or divide by a negative number, if you want to get the inequality solution correct, you'll have to flip that sign. Okay, and so we've got it solved. If we wanted to graph it, here's my 0, negative 17 over here to the right somewhere. We want the values that are greater than negative 17, so we want all this stuff over here to the right of that. That's where our solution set lies. And then we do want to include negative 17 in our solution because of the equal sign on our order symbol there. Okay, so negative 17 is our leftmost point. We're going to start there, work our way across, go to the right forever. So that's going to infinity, and then bracket on the left, and then infinities and negative infinities will always get parentheses. Okay, so hopefully that's enough to get you off to a good start with this linear inequality lesson. Please don't hesitate to let me know if you have any questions. Have a good day.